I've included enough detail in this section for you to be able to create a good process model. Now, there are a number of different modeling techniques that have emerged in the business process management subject area. Luckily, most of them have a common theme that aims to produce a flow model of some kind for the organization. To teach this section in process analysis, I'm going to use a process model called a data flow diagram. In this section, we'll cover typical symbols used for process modeling, modeling external interfaces, modeling data and control flows, modeling stimulus and non-stimulus flows, modeling diverging and converging data flows, modeling processes, the 3 allowable process types on an analysis model, modeling stored data, an additional helpful modeling symbol, summary of the rules for process model symbols, a sample event-driven process model, and the best way to produce an event-driven process model. In analysis modeling, we use a set of symbols to be able to specify business aspects without their design cover. In process analysis, the most important aspect to model is the flow of data through its processing. A good model for depicting this is a data flow diagram, also known by its acronym DFD. This slide shows a basic established symbol set for a data flow diagram. Let me give a brief definition of the symbols here, but I'll get more detailed on the following slides. In the table on this slide, the first column indicates the design or real-world aspect of the organization being modeled. Then next to it, I've shown its equivalent analysis process model symbol. Let me go through these. The top row in this table shows an external interface, for example, a customer, a clock, a calendar, etc. These are things beyond our organization and beyond our control. The symbol we use for an external interface is a rectangle. In the business world, the external interface is usually the customer. But remember, the customer isn't always a human being. I think I mentioned on one project I consulted with the US Bureau of Land Management, the customer was the land. The second row shows an item of data flow and its media. For example, the verbal communication of an order, written communication on a form, electronic communication on a computer screen, etc. The symbol for a data flow is a line showing the direction of flow. The next row shows a human task, procedure or process, or a computer task, program or process. The symbol we use for a process is a rounded rectangle. Next row shows a file or stored data and its mediums such as a file cabinet, database, etc. The symbol we use for a store is a pair of parallel lines. The next row shows a control flow such as a date triggering a significant event from a calendar, a point in time which may be based on an alarm, time, trigger, an incident such as a fire has broken out which may come from a detector, etc. This is a flow without data content. The symbol we use for a control flow is a dashed line showing the direction of flow. Note that there are extensions to this set advocated by technical groups, and I even have some I will recommend in this section. Whereas I do feel that consistency in the use of symbols within an organization's documentation is important, I don't want you to get adamant about the symbols used for a particular flow model. Just make sure that whoever is going to use your analysis model understands the symbols you use. For the rest of this section, I'm going to concentrate on the definition and use of each of the analysis process model symbols shown in the right column of this table. Those symbols are the most common and will serve as well for most business process modeling. Let's discuss modeling external interfaces. First, the definition. An external interface is where events occur and where input originates or output terminates from the point of view of the area under study. An external interface identifies the boundary of the area under study. It is represented as a rectangle with the name of the external interface written inside the rectangle. As shown on this slide, an external interface can be an individual, such as a customer. It can be an organization, such as a bank. It can represent a calendar or clock. It can also be a device, such as a meter or thermostat. I've shown a couple of additional symbols I use on the right side of this slide. One is what I call an internal interface. If we're restricted to studying a limited area, or we are part of an analysis team responsible for studying just part of an organization, hopefully so we can come together later and combine our models, then we could use a dashed rectangle to indicate an internal interface. This would indicate an area that should link up later to other process models. The internal interface may be some department, bureau, or system that is within the organization. Another extension symbol I use is an external store, a file, indicated by a store symbol within a rectangle. I'll talk about stores soon in this section, but we have a rule for stores. All data going into a store should come out of that store somewhere on the model. But this is not true for stores such as a store of present currency exchange rates or tax tables. We may get data from them, but not be allowed to enter data into them. External interfaces are by definition beyond our area of study. We're not allowed to change these areas. However, we should try to use descriptive non-design names for them on our model. Avoid people's names that will make the model out of date when that person is replaced. For example, Bert, who may be the external auditor. Also, names that reflect old external design boundaries should be avoided. For example, the current midnight pickup, that's really the express mail external service. As you may have guessed, the most important things on a data flow diagram are data flows. So this slide describes how we model data and control flows. First, the definition. A data flow symbol indicates a flow of information or business objects. Notice that definition says objects as well as information. Many initial users of data flow diagrams thought they could only show data fields on the flows, not objects or things. But if we're trying to capture business issues on an analysis model, and an object is an aspect of the business, it should be shown on the model. In other words, if we sell widgets, we should see widgets somewhere on the process model. In one of my early system development methodology books, I showed a data flow diagram of the process of installing a system into production. One of the processes on that data flow diagram was train the system users. The input was human beings, users and staff, and the output was trained human beings, trained users and staff. The process would have made no sense if it didn't show the people in and out of the training process. So physical things are shown on the model if they are part of the business and not just an aspect of design. A data flow is represented as a directed line with the name of the data flow written in singular form through or next to the line. The name for a detailed data flow should be in the form of a direct noun with optional adjectives, as shown in the example on this slide. The arrowhead on the line indicates the direction of the flow. For intermediate analysis models, we can include design characteristics on the data flows such as customer refund check or receipt back copy. However, these should be replaced in the final analysis model, as a new designer may read these as mandatory in the new design. I always teach that a data flow disappears, just like spoken words do, once it's reached its destination, such as a process. In other words, it's no longer available unless it's stored. A control flow symbol indicates communication without data content. A control flow is indicated as a directed dashed line with the description next to it. We name these flows with descriptive text in quotes, as shown in the examples on this slide. End of fiscal year, fire or flood. Another example of a control flow might be when a device senses heat or movement. This symbol is used to show acknowledgement of that control trigger. Remember, control flows have no value, at least not until we give them a value in design. However, if there is a data value in the control trigger, show a data flow instead of a control flow. So in my example here, if the fire flood control flow gives the location of the fire or flood, then show a data flow on the model and name the data flow, for example, fire flood location. Be cautious of design-oriented control flows, such as the ones in the lower right diagram. They usually indicate something that falsely breaks up processing in an event reaction, or they trigger processing that is an aspect of design. I'll talk more on this later. Some modeling methods recommend showing input control entering a process from above and output control leaving from below a process. Control is primarily a design issue in business systems. However, there are, of course, business controls. Control flows are common in real-time systems. Over my years of using data flow diagrams, I've found it useful to identify what starts up a process. So I've added this slide on modeling stimulus and non-stimulus flows. This is an extension to the original symbol set. A process does not start up on its own. It needs to be stimulated into life by a data flow or a control flow. It's helpful to indicate the stimulating data flow or flows, or business control flows, with a slash symbol across the flow as shown highlighted in the examples on this slide. I've indicated with a slash that the credit request data flow triggers the confirm customer request process, and the slash on the January control flow triggers the produce W2 process. Note that all data flows to and from stores, files such as credit history and year-to-date payroll files, are by definition non-stimulus flows, because stores can't trigger processes. Stores are inanimate, they wait for processes to put stuff in or take stuff out of them. I think of non-stimulus flows as being pulled in or being output from a process based on stimulating flows. In the lower left example, I've shown the stimulating data flow loaded plane triggering the process create flight plan. What is unusual about this particular process is that it pulls in the current weather conditions from the external interface, the Weather Bureau. It's unusual because external interfaces usually trigger processes, but in this case the data from the external interface was not the trigger. I conducted a lot of seminars at the package delivery company Federal Express, and in one seminar in Memphis, Tennessee, the students took me through the main hub at night where packages were sorted and loaded onto planes. The interesting thing to me, being used to regular passenger airlines, was that there was no schedule as such for the planes. When the plane was loaded with packages, it took off. That's what this example shows. It also would not have been wrong to show the Weather Bureau as an external real-time store. We can assist in creating complete event reactions, bringing together of historically fragmented systems, by always indicating the stimulating flow throughout our model, as shown on the lower right diagram. This will force us to look for the next process, if any, that an output flow from a process would trigger, and therefore show the complete reaction to an event. There's even more to say on data flows, specifically modeling diverging and converging data flows. Split or diverging data flows indicate a distribution of the same data to many destinations, with no actual transformation of data content or status. This is shown in the top example on this slide, where the employee payment goes to many destinations. Diverging data flows are commonly used on DFDs. Although rarely used, component data flows can be extracted from the main data flow, such as this same example showing just the account ID and pay amount going to the bank. Converging data flows indicate a collection of data flows that form a single data flow with no actual transformation of data content or status. An example is shown in the middle diagram here. Year-to-date taxes and FICA, FICA, are included in the employee yearly statement. Although converging data flows are technically correct, they tend to be rarely used. As shown in the lower example, sometimes we may see a double-headed data flow, especially on high-level diagrams. Two-way data flows, as they're known, are treated as separate independent data flows. They tend to be used to reduce the complexity of a diagram. We show the name of the data flow closest to the directional arrowhead. In my example, customer payment flows to the right, and customer receipt flows to the left. I tend to find almost all my students think process first. This was also true for me throughout my early career. Everything was process-oriented. I concentrated on a system, subsystem, module, department, division, procedure. Later on, I found myself focusing on data issues, a data model, data entity, data dictionary, data elements, databases. In fact, on a data flow diagram, data is somewhat more important than processing. Of course, we should show both, but I recommend we focus on data first when creating a data flow diagram. So be careful of modeling flow control, that is, concentrating on processes without showing the data used in the processes. In a data flow diagram, data is the guiding aspect. Concentrating on data flow first will help produce a more valid analysis model. In the lower example on this slide, I bet you can come up with some fairly accurate names for the processes shown, just by looking at the data flowing in and out of them. Process names such as validate meter reading for the first process and calculate power usage for the next. But it would be a lot harder to name the data flows given just the process names. Now, the second most important things on a data flow diagram are the processes. I have a general rule I say in my analysis seminars. Data is processed, and process needs data, at least in business systems. So a good analysis flow model shows both. A process symbol indicates a transformation of input, data or control, into output, data or control. A process is represented as a rounded box with a brief process description and an optional reference number written in the box. The name for a detailed process should be in the form of a specific verb and a direct object, as shown in the examples on this slide. Process customer order, validate payment, and calculate sales tax. However, the name can be more descriptive, for example, match payment to outstanding invoice. Process names on high-level models can be less specific, such as process customer order. We'll talk about level DFDs later. There's no rule that says we need to use cryptic process names, but remember that every detailed process on a data flow diagram is backed up with business policy or logic using a process specification. So we should make the diagram readable without writing whole sentences as process names. A reference number for each process shown at the lower part of a process symbol is helpful for large analysis efforts, as process names may change with the reviews, but reference numbers don't have to change. But note that the reference numbers do not represent a sequential order of processing. Stimulating data flows govern that. I'll talk more on this in a later section. For intermediate analysis models, we can include design characteristics. I've shown in my examples on the right here that Pat is the person who performs the validate payment process, and accounting department performs the calculate sales tax process. There are many variations on the notation used for modeling processes in other techniques, such as ellipses for use cases in Uniform Modeling Language, UML, and rectangles for processes in Business Process Modeling Notation, BPMN. DeMarco's original symbol for a process was a circle. However, the most popular symbol for a process seems to be a rounded rectangle, so I'm going to use that for my examples in this tutorial. Remember, the model is not as important as the business requirements we want to capture with it. As the years go on, there may be changes to the models and their notation, but to me, analysis concepts stay the same. Now here's an important slide in this tutorial. There are 3 allowable process types on an analysis model. For a process to be valid on an analysis model, it must transform its inputs into outputs in one of 3 ways. It must produce new output, for example, another named data flow. In my top example on this slide, gross pay is used to produce federal taxes, a new output data flow. This process transformation type is easy to recognize. Or a process must change an occurrence value of data from its input to its output flow. In my middle example here, customer balance is used to produce new customer balance. Notice the same input and output data flow name, customer balance, but a value change has occurred in the process. I recommend we put parentheses around an adjective on the output data flow name. In my example, new is in parentheses. This means only one definition of the input and output data flow customer balance is needed in the data dictionary. This process transformation type is somewhat easy to recognize. Or a process must change the status of a data flow. In my lower example here, customer charge is used to produce approved customer charge, a status change for the same data item. In this example, the data flow name is the same, and even the value of that data flow in and out of the process is the same, but its status has changed, is now approved. This process transform type is the hardest to recognize. Again, I recommend for a status change, we also use parentheses around an adjective on the output data flow name to show a transformation has taken place in the process. The model then becomes more readable, and the number of data dictionary definition entries is reduced. I'll talk more about this in the data dictionary section. Even though we're mostly interested in data flowing on a data flow diagram, we also want to acknowledge data at rest, stored data. The data store symbol indicates data at rest. A data store is represented by 2 parallel lines. The descriptive name of the content is written in plural form between the lines. Remember, data flow names are shown in singular form, data store names are in plural form. That makes a difference when we get to definitions in the data dictionary section. I've shown a customer store and an order store in the example on the left of this slide. Stores usually contain repetitions of a data element or data elements. However, there's nothing wrong with storing one set of data elements, such as an organization's incorporation record. For intermediate analysis models, we can include design characteristics, such as in the example on the right side of this slide, where the customer store is currently known as the master file, and the orders file uses a wire basket. Remember, any content in a data flow disappears after it's used in a process or sent to an external interface. So if we need to keep it around until another point in time, for example, end of fiscal year, or until another external data flow arrives, for example, keep an invoice until the payment arrives, then we must put it in a store. Here's a rule that I created after struggling on many projects in the early days with the need for stores. The only stores that should appear on an analysis model are those needed to share information between two event reactions or two occurrences of the same event reaction. So in the example I just used, where we need to keep an invoice until the payment arrives, the event reaction that created the invoice needed to share that invoice with the event reaction that processes the payment for that invoice. So a store is needed. An example of two occurrences of the same event reaction is an event reaction that raises a product price 5%, then another later occurrence of that event reaction that raises the price 10%. A little technical there, but it's important when we see that data stores form the link between process analysis and information analysis. We'll talk more on this later. There's an additional symbol that can be helpful in analysis process modeling. An asterisk symbol indicates duplication of an external interface, data store, or process within a diagram. It is usually used to help create a readable, flowing data flow diagram and reduce cross-data flow lines on a complex model. As shown in the lower example on this slide, rather than having all data flows originate and terminate at one modeled customer external interface, we can duplicate the customer on both sides of the model and connect the data flows to each to make the diagram flow. It's not necessary to show duplication of data flows with an asterisk, as we use a split data flow symbol to show the same data going to two or more destinations. When used in a process, the asterisk indicates a reusable process. There are many other symbols that can be used when specifying a system. For example, BPM-N, Business Process Modeling Notation, and UML, Unified Modeling Language, have quite extensive sets. However, the set of symbols described in this section will serve well to produce an analysis specification process model. So here's a summary of the rules for process model symbols. If it moves data from one place to another, then it's a data flow. If we need to communicate without data content, then it's a control flow. If it manipulates or transforms data and/or controls, then it's a process. If it holds data within the system until it can be processed later, then it's the data store. Now the last rule takes a little setting up. You see, projects, systems, and organizations, and even event reactions, have boundaries. If we're allowed to study beyond these boundaries, we would find other data flows, processes, and stores. So when conducting business process analysis, we can define the boundary by using the following criteria. If we have no control over its procedure, content, or timing, then it's an external interface. In other words, the boundary of the area of study. As I've said many times before, the analysis process model does not show any design characteristics. On this slide is an analysis process model that I have shown before. It has no design characteristics shown. It shows one complete detailed event reaction. I want to use it to list the design characteristics that it doesn't show. Remember, we want to capture an analysis model that will last as long as the organization is in the line of business identified in the model. As analysts, we don't want to restrict or influence the designer of any new system with design characteristics in our analysis requirement specification. So when technology changes occur, and they will, the analysis model is still valid for the organization. As with any correct analysis model, this model does not show any design characteristics such as human errors or corrections of them, computer errors or corrections of them, backup restore processes, nothing can go wrong on an analysis model, current design timing, essential business timing is fine, internal audits, external audits are shown, management sign-offs and approvals, human department, divisions, bureau boundaries, computer macro program system boundaries, physical media of data, paper, file cabinets or databases, human or computer data access issues, sorts, merges or extracts. Analysis files are similar to the human brain. You can get at anything in any order. And job titles, roles, names, computer IDs, etc. All these are aspects of the old or new design. Remember, the system designer is not allowed to change the analysis specification, just like a carpenter can't change any aspect of a room on a blueprint that was requested by the owner. There's nothing on this model that restricts the designer from using the best technology available today. Let me show you how I created the process model on the previous slide. Now this is an important slide to me. As the last slide in this section, I want to tell you the best way to produce an event-driven process model. It's the technique I always use when I'm called in to do real work and practice what I preach on a consulting assignment. I call this technique interviewing the data flow. With this technique, I want to give you the same feeling of confidence that I have when I go into a new organization or even into a new type of business that I've never modeled before. Using an event stimulus flow entering the organization, we track it through all of its processing until it terminates in a data store or an external interface. Those are the only two possible terminations for a data flow. On the diagram on this slide, I've shown the existing design of an area of business. Using the interview the data flow technique, we stick with the stimulating data flow through all its processing in the existing systems and ask the business users and staff what happens to this data as it goes through their jobs. We also follow the data flow through any computer programs containing business policy. We may need help with this if the computer language used in these programs is not known to us. The original flow and its ongoing derived flows in the existing systems may be implemented on a form, a screen, or even by word of mouth. We don't care about its media in analysis. Now, the stimulating data flow may diverge. In other words, subflows go off to other processes. However, we stick with the main flow and return to the offshoots later. That is, follow one complete set of data and processing straight through the whole organization. This will form one complete event reaction process model. We produce the diagram on the right of this slide by applying this technique to the existing implementation shown in the diagram on the left of this slide. If you're a one-person band organization, this just means identifying each individual task you perform to deliver a result out of your organization, given one event stimulus. If you have multiple employees and even computer systems, this involves identifying each process regardless of who or what computer program does the process. This will produce a business model without any design implementation boundaries. Now, this interview the data flow technique would produce the existing analysis process model, and we may need to update it with any new changes to the business requirements for it to become the new analysis process model. On the analysis process model on the right, I've shown the result of this procedure as a continuous set of data flows in red through the processing in the organization. So we now see the complete analysis process model result for one event reaction. We apply this technique to all events in our organization. Remember, as analysts, we don't invent anything. Our job is to capture all the business requirements. So this model and all its supporting documentation for all events is the business process analysis result. Now, you should be able to read all the symbols on the process model on this slide. Notice, to make the diagram more readable in a left to right flow, I have duplicated the customer external interface and used an asterisk in the symbol indicating it's the same customer. That was a comprehensive section.